to market effectively. In the UK, we're currently working with transmission system operators and the UK government, looking at the role that hydrogen will play in Scotland's net zero roadmap. So that includes the potential generation of a hydrogen economy, potential export for the field as well. So we're working with the Scottish Government, for example, on Scottish looking at creating a hydrogen economy in Scotland and then exporting that additional hydrogen generation capacity to Germany as part of the wider energy security concerns that are happening at the moment. And then further afield in Chile, we've recently been awarded conceptual engineering for Total Aren's H2 Magallanes project, which is a large-scale green hydrogen production facility. So our scope on that covers the development of the complete complex integrated energy grid effectively to produce ammonia from green hydrogen. So that engineering package includes up to 10 gigawatts of installed wind capacity and up to 8 gigawatts worth of electrolyzers, as well as the desalination plant, the ammonia plant, the power transmission and backup and port facilities for international export as well. So hopefully that gives an indication of sort of the breadth of industries that we're supporting in the hydrogen economy, as well as the fact that hydrogen truly is a global economy at the moment, and there's a wide range of countries that are looking into potential hydrogen production and end use. So the reasoning behind that is being driven by broader decarbonisation policy effectively. So as of last year, over 66 countries had announced net zero emissions targets, and most of those had a decarbonisation strategy behind that, of which hydrogen needs to play an important part. The knock-on effect of that obviously is that large multinationals that are based in those countries with the net zero targets that also have a presence in other countries are looking to force the issue effectively from the supply chain side, and effectively are introducing pseudo net zero targets in those other countries as well. I think there's general agreement on the need for incentives and support to incentivise effectively these net zero and hydrogen projects, but it's not always clear when, where or at what levels those incentives will be set, and that's something that a number of countries are currently working through at the moment in terms of government funding incentives and support to get these projects kicked off either at the pilot phase or at the full scale project execution. Just to put in context, I guess carbon pricing is obviously a strong signaling metric that's often used by analysts to gauge when hydrogen might become commercially cost competitive. So in context, at $1 per kilogram of hydrogen production, which is at the very lower end of the scale in terms of the potential price of hydrogen production, is very cheap. That's obviously based on the kind of the 2050 scale production requirements. But at that $1 per kilogram delivery cost, a $50 per tonne of CO2 carbon pricing would drive a case for switching to hydrogen use in the steelmaking industry. At $60 per tonne CO2, that would drive a switch in the cement industry, and at $90 per tonne, it would drive a switch in the aluminium and glass industry. So it really shows that it is a balanced equation, and that obviously we need to drive down the overall cost of hydrogen production, as well as balancing it with potential carbon pricing incentives from governments to ensure that producers and end users are switching over to hydrogen use as well. So briefly running through the different types of hydrogen generation. So as I mentioned previously, we have the traditional grey hydrogen, which is conventionally formed through a methane feedstock, either through steam methane reforming or autothermal reforming. So as I mentioned earlier, our track record in that is we've designed over 120 hydrogen plants globally with a wide range of capacity. But that's now being replaced effectively through either bio or blue hydrogen. So blue hydrogen is the same production methodology, but also includes carbon capture technology, pre-combustion, to reduce the total amount of CO2 emitted as part of that process. In the first session after the break, we'll go into a bit more detail on the different types of blue hydrogen production and the different types of carbon capture technologies that can be introduced in that. Wood's also currently developing biohydrogen technology, so we're looking at liquid bio feedstocks instead of methane feedstocks for the hydrogen production process, and we're currently running through technology readiness levels for that technology. But then ultimately we have green hydrogen, which is produced from renewable power effectively, and then through electrolysis to produce the hydrogen, so it effectively has the least amount of CO2 emissions. Obviously, today, current electrolysis technology is at a relatively small scale, but we are obviously seeing that massively scale up and significantly large gigawatt scale projects being announced globally. In general, as we kind of move to the right, cost generally increases and maturity reduces effectively, but it's clear that the cost of green hydrogen is rapidly reducing as we're seeing the projects start to scale up and as we're seeing more electrolyser suppliers into the market and a bit more diversity in that respect. So moving on to the hydrogen value chain. So if we start to look at the hydrogen value chain, we can start to see how those technologies can combine for producing hydrogen, as well as the wide variety of industries, domestic and transportation consumers as those end users. So the real complexity is how we transport those hydrogen and what's driving those integrated developments to realise the economies of scale. So there's a real need for those integrated products to have a systems designed effectively to optimise themselves. So, for example, where do you locate the hydrogen production in relation to the end users? How do you transport between the two? Is it cheaper to move electrons through electricity than it is through molecules through hydrogen? So where do you balance that? Where do you have that balance? So one of the key themes you'll see through the series of workshops this afternoon and through the discussion is the need for collaboration between industries, end users and hydrogen producers to really optimise the overall system design of these hydrogen projects. Also thought it was worth mentioning the overall risk flow when it comes to hydrogen projects and, to be honest, net zero projects in general. So if you look at the four main stakeholders when it comes to energy projects, you have your owners, your financiers, your technology providers and your engineers. And one of the key challenges when it comes to hydrogen projects or net zero projects in general is that effectively there's disruptors for each of those four main stakeholder groups. So when we look at the owners, the majority of net zero projects are effectively at cost to the owner, depending on the carbon pricing that we mentioned earlier. Financiers are looking for a kind of a traditional return on their investment. Technology providers are looking to take on significant guarantees for their developing technologies. And ultimately what that means is the combination of the owners and financiers are looking to push down the risk and ensure surety of their investment. So what that ultimately means is that the technology providers and the engineers are being squeezed for, in a lot of instances, lump sum turnkey requirements on first-of-a-kind technology and taking on the process guarantees for the development of that technology. So I think one of the key challenges for hydrogen production in general is what is the appropriate risk-sharing model between those four stakeholder groups to make sure these projects are actually realised, and how do we make it happen? Who else needs to get involved in that process? Where does government get involved? What role do they have to play in de-risking the process from start to finish to ensure these projects go ahead in real time? So I think if you look at the engineers, for example, if the engineer is being asked to take on a significant amount of risk in the project, then they will obviously have to price or design for that risk, which potentially doesn't lead to the optimised overall system design for either the client or society in general.
Excuse me? We're going to have a Q&A later. We can interrupt you as you speak.
Yeah, so we'll have a Q&A session after the second presentation, so we'll take all the questions there. That's good. So I guess what challenges still exist for hydrogen production? In the next session we'll go in a bit more detail on specific delivery challenges for hydrogen projects. But I guess these are the kind of general challenges when it comes to establishing a hydrogen economy. So obviously investment, there needs to be significant investment in hydrogen, whether that's leveraging government funding schemes or whether that's people taking a risk effectively on hydrogen production and balancing that end use demand requirements. Technology, developing at commercial scale to reduce costs. As I mentioned, there is that end goal of $1 per kilogram hydrogen production cost, but how do we reach that? How do we drive down costs through scaling, modularisation, etc.? Finance, where is that funding source coming from? How do we de-risk the project for everyone involved? How do we de-risk it for the owners and financiers as well as the contractors and engineers? Policy, obviously there's a lot of talk about policy and how we drive through hydrogen production and end use through policy. So how do governments get involved in that and set around building the hydrogen economy to make sure that everyone is brought into it. And finally, the go-to-market. So obviously there's strategic action there required to deliver success. What is the go-to-market route for hydrogen? As I mentioned earlier, we're seeing a lot of countries looking to establish a hydrogen economy for potential export, and as we'll see in the next presentation, there is a lot of hydrogen demand out there for countries that can't produce the hydrogen themselves. So there is massive export potential opportunities for hydrogen projects globally. So hopefully that gives a very high-level overview and introduction to the hydrogen economy, as well as a bit of context on its capabilities and track record and current projects that we're working on. But obviously, as I said, we've got the Q&A session coming up after the next presentation, so you get an opportunity to ask a lot more details. And then after the Q&A session, we'll be running through a networking session outside. So if you have any follow-on questions, please don't hesitate to grab me or one of my colleagues and ask any more questions. Thanks very much. That's the end of the first session. We'll move on to Anna Thrones.